Assalamualaikum, we're from Group 3 and today we will be presenting on semiconductor technology industry, focused especially on the market structure of Malaysia's semiconductor sector. And this is our team.
Good day everyone, my name is Lintinya Matrikno 29759. I will present the framework and our 11 selected semiconductor firm. First, we use the SCP paradigm to analyze market structure, firm conduct, and financial performance under government policies. Now looking at the 11 firms. 1. Unicef, an oligopolistic capital incentive player. 2. Turia, provides specialized chemical engineering infrastructure. 3. MPI, a leading global OSAT partner under an IMP 2030. 4. KESM, specialized in high-tech burn-in and testing. 5. Inari Amaton, a prominent back-end heavyweight driving high volume. 6. Globaltronics, manufactures advanced integrated circuits and optoelectronics. 7. Flocon, specializes in precision cleaning for chip equipment. 8. Vitrox, driven by high R&D and vision inspection. 9. D&O, manufactures high-performance automotive LED electronics. 10. DHM, focus on microelectronics packaging for automotive use. 11. NSIC, specialized in turnkey and SiC and LOT solutions. In conclusion, this firm reflects the diversity of Malaysia's semiconductor sector. Thank you very much.
Assalamualaikum, today I will be presenting on the market structure of Malaysia's semiconductor industry, which is classified as a high concentration oligopoly. The market consists of 11 firms on Bursa Malaysia, which the top 4 firms, namely MPI, Malaysia Pacific Industry, Unisem, Inari and D&O, capture more than 75% of the total market share. Looking at 4-firm concentration ratio from 2017 to 2023, it has consistently remained above 70% every year. In 2023, it reached in peak at 76.54%, according to Stan Market classification at CR4 between 60% and 80% indicates a highly concentrated oligopoly. This means the top 4 firms hold significant market power to influence price and shape industry direction. In terms of market revenue, the industry experienced impressive growth from RM 6.2 billion in 2017 to an at-all height of RM 8.81 billion in 2022, driven by a global chip shortage during the post-pandemic period. However, 2023 saw a cyclical downturn to RM 7.65 billion due to global inventory corrections. Despite this, dominant leaders like MPI, Malaysia Pacific Industry, and Unisem remain resilient due to the massive financial scale. Nature of product. This industry offers heterogeneous or differentiated product, which can be grouped into 3 main categories. First, offset service like chip package and testing, which can be related homogeneous, leading to more intense price competition. Second, automotive competition, such as sensor and LED, which have experienced massive growth driven by a global EV demand. Third, specialized system like Vitrox inspection machine and key ASIC custom chip design, operating in nickel market with less competition. For the slight market sales trend and cycle, the industry experienced a post-pandemic boom in 2022, with revenue hitting RM 8.81 billion, driven by a chip shortage and digitalization. But 2023 brought a cyclical correction to RM 7.65 billion due to inflation and oversupply. Yet, top firms like MPI and Unisem preserve their market power through the sheer financial scale. The slight barrier to entry. Finally, this industry has an extremely high barrier to entry. First, at economy of scale, top firms generate over RM1 billion in annual sales. Second, capital intensity, setting up a medium scale or set facility required RM500 million to 1 billion in upfront investment. 3. Technology and IP access, protected by a patent and required intensive R&D. And 4. Global customer trust, long-standing relationship with giants like Apple and Huawei, plus certificate like IATF 16949 and take years to obtain. This barrier means no significant new entrants have emerged, and the CR4 continues to rise year after year. In conclusion, Malaysia's semiconductor industry is a highly concentrated oligopoly where 4 large firms dominate in the market. Product like heterogeneous through the offset segment is more homogeneous, high entry barrier, ensure the structure remains stable and difficult for any new players to challenge.
In Malaysia's semiconductor industry, firms adopt 3 main pricing strategies. OSATs like MPI, Unisem, and Inari Amatron use cost plus pricing, where price equal production cost plus margin. This requires massive capital investment, often between 500 million and 1 billion ringgit, but is vulnerable to raw material, labor, and foreign exchange risk, and depends on government incentive such as the investment tax allowance and pioneer status. Competitive pricing reflects the oligopoly structure with concentration ratio for above 70%. Firms adjust price in response to rivals, globalization pressure from Vietnam and China, and trade policies like ROHS compliance and United States sanctions. Meanwhile, niche innovators such as Vitrock and Fronken adopt value-based pricing. Their unique technologies, AI inspection system, and precision cleaning allow them to charge premium price, achieving gross margins above 45% compared to the OSAT average of 20-25%. Research and development is the backbone of Malaysia's semiconductor competitiveness. Large firms like MPI, Unisem, and Inari invest billions of ringgit in automation, wafer packaging, and radio frequency technologies to boost efficiency and global competitiveness. At the same time, innovators such as Vitrock, Fronken, and Key ASIC drive breakthroughs in AI inspection, precision cleaning, and ASIC design for Internet of Things and artificial intelligence. These innovations create temporary monopoly power, what Shamter described as innovation-driven advantage. Government incentive, including the investment tax allowance, pioneer status, New Industrial Master Plan 2030, Green Investment Tax Allowance, and the National Semiconductor Strategy, aim to channel 25 billion ringgit into research and development by the year 2030, ensuring Malaysia moves into high-value, sustainable, and future-ready semiconductor markets. Corporate social responsibility strengthens Malaysia's global credibility. Environmental compliance with ROHS, REACH, and the Environmental Quality Act 1974 is essential for export and reputation green technologies such as D&O's energy-saving LEDs and Globetronic optional sensors aligns with ESG standards and enhance competitiveness. Workforce empowerment programs from MPI's automation training to Unisem's workplace safety initiatives, scholarships, and STEM projects build talent and community trust. Best practice benchmark Malaysia against global leaders like Intel, Taiwan Semiconductor Manufacturing Company, and Samsung, showing that the industry is not only technologically advanced but also a responsible corporate citizen.
Assalamualaikum warahmatullahi wabarakatuh. So now I will talk about industry revenue trends that show how the top 4 semiconductor companies in Malaysia performed from 2017 to 2023. If we look at the first slide, we can clearly see the 2022 peak and 2023 drop. The whole industry hit a massive high together in 2022. Then a global market slowdown hit everyone during 2023. Now, when it comes to Malaysia Pacific industry and Unisem volume leadership, these two are definitely the heavyweights here. They consistently pull in the highest baseline sales volumes in Malaysia. On the other hand, we have Inari's mid-period stability, which shows a really steady, resilient revenue line over the 7 years. But the real highlight on this graph is D&O Green's 2023 defense. While the other 3 big players drop, D&O Green company was actually the only company that completely escaped the crash and just keep growing. Moving on to the next slide, the actual total numbers this company made over this period, which is first we have MPI at 12.56 billion ringgit, which make they are the undisputed top earner, easily clearing over 1.5 billion ringgit every single year. Then we have Unisem at 10.02 billion ringgit. They kept up a really strong presence, especially after 2022, where they stabilized comfortably above 1.3 billion. Next we have is Inari at 9.09 billion ringgit. They show a really solid defensive performance and even hit a massive peak of 1.55 billion ringgit in 2022. Lastly, we have D&O Green at 4.88 billion ringgit. Even though their total numbers is smaller compared to other three companies, they are definitely the growth star because they literally doubled their sales capacity over these years. Finally, we are going to look at the main risk that the four companies faces. First, there is the fixed overhead burden because these companies have high factory capital expenditure. They get hit really hard during the market dips because those expensive machines cost money even when orders dry up. But look at the niche market installation. This is exactly why D&O Green did so well. They focused strictly on automotive LEDs, which kept them safe from the smartphone and tech recessions that hurt the other companies. The big issue for the other three is the break-even value trap. As OSAT providers, they need non-stop and massive orders running through their plants just to stay profitable. So the big takeaway here is size versus specialization. It shows us what the big right target market rather than just being a huge company is what actually helps you to survive in a downtown during economic crisis. So that's all from me. Thank you.
Good day to our lecturer and fellow classmates. Today we will explore the strategic management and regulatory impacts on Malaysia's semiconductor industry. Let's begin with slide 1, focusing on subtopic 5.1, the National Semiconductor Strategy or NSS from 2024 to 2026. To propel our electronic ecosystem forward, the Ministry of Investment, Trade and Industry or MITI has introduced the NSS with a massive fiscal allocation of 25 billion ringgit, which is equivalent to roughly 5.3 billion US dollar. This strategy roadmap marks a critical high-value shift for our country, moving our industry from low-margin back-end manufacturing like traditional OSAT and actively pushing towards high-value subsectors such as integrated circuit design, advanced packaging, and also AI-driven manufacturing. To sustain this growth, the government is also focused on lowering barriers to entry for local startups. By cultivating a skilled workforce through the Engineering Talent for Semiconductor Industry or ETSI program, this strategy successfully bridged existing technology and knowledge gaps. This massive initiative directly alters corporate and research development behavior. For instance, design firms like Key Essex, Berhad are now leveraging public funding to develop and patent their own custom silicon intellectual property blocks. Concurrently, we see a huge surge in forcing dominant oligopolistic leaders like MPI and Inari Emerton to upgrade their operational behaviors and heavily invest in advanced packaging just to maintain their global competitiveness. Slide 2 covers subtopic 5.2, which examines the strict environmental regulations that govern semiconductor manufacturing right here in Malaysia. Semiconductor operations naturally generate highly toxic chemical waste, such as hydrofluoric acid and engineering solvents. Under Malaysian law, specifically PU A294 2005, those chemicals are legally classified as scheduled waste. This framework is rigidly enforced by the Department of Environment under the Environmental Quality Act 1974. Under Regulations 8 and 9 of this framework, factories face strict on storage limits. They are legally prohibited from storing scheduled waste exceeding 20 metric tons or keeping it for longer than 180 days on site without explicit written approval from the Director General. To ensure full transparency, every single firm carries mandatory reporting obligations to systematically label, log, and track each industrial byproduct using official scheduled waste codes. This compliance has a direct impact on financial performance. Industrial support firms such as Turia Berhad for chemical plating and Franken Corporation for precision cleaning are forced to allocate massive capex for waste treatment. For smaller companies, this compliance costs several strained profit margins, as clearly seen in Turia Berhad's performance, where their return on assets has hovered close to 0%. Moving on to slide 3. We look at subtopic 5.3, the Global Automotive Quality Framework, specifically focusing on the newly enforced IATF 16949 Rules 6th edition. This is a mandatory private regulation. Local chip manufacturers must rigidly comply with this international quality standard if they want to secure supply contracts with global automotive giants, as well as our domestic brands like Proton and Perodua. This framework became fully effective on 1st January 2025, bringing much tighter controls to automotive semiconductor quality management. One of the most critical change in this 6th edition is the geographic audit zone restriction, also known as the 16-kilometer limit. It dictates that extended manufacturing site must be located within a 10-mile or 16-kilometer radius of the primary plant to share a single corporate certification audit. If a site exceeds this distance, it requires a completely separate and costly audit, which can disrupt corporate certification. These new rules creates major strategic impacts on our key local firms. Companies like MPI and Unisem are actively realigning their logistic and geographic positioning of packaging plants to prevent audit failures. At the same time, Inari and DNO Green are tightening controls over their high-frequency radio frequency packaging lines and automotive LEDs, using advanced monitoring methods like FMEA to hit zero defect targets. Looking at the technical side, KESM is investing heavily in rigorous burn-in testing methodologies, while Vitrox is programming its AI machine vision system to perfectly catch defects specified by the IATF. Finally, JHM consolidation is forced to efficiently balance this rigid automotive standard alongside complex AS 9100 aerospace frameworks to drive successful vertical integration. Our final slides cover subtopic 5.4, addressing national security, export compliance, and the Strategic Trade Act 2010. Advanced semiconductor chips are legally classified as dual-use good. This means they possess capability for both civilians, commercial applications, and military hardware, making them a serious matter of national security. In Malaysia, this strategic border control is regulated via the Strategic Trade Act 2010, which is administered directly by the Strategic Trade Secretariat under MITI. Because of this law, mandatory export permits are strictly required. Semiconductor firms must pass extensive background checks before exporting high-frequency components or microprocessors overseas. This creates free market restrictions, meaning back-end exporters and component manufacturers like Inari, MPI, Unisem, DNO, Globaltronics, and KESM are legally barred from trading freely with any entities or countries placed under global sanction lists. Furthermore, upstream intellectual property protection is absolutely vital. Automation software developers and custom design firms such as Vitrox, JHM, and KSX must heavily safeguard their software, codes, and microcontroller designs against cross-border leaks. Ultimately, ongoing geopolitical tensions, specifically the tech decoupling between the US and China, forced these 11 public listed firms to strategically alter their market behavior. They are diversifying their customer portfolio into neutral zones to safeguard their financial returns, such as their return on asset and return on equity. In conclusion, we can see that operating a semiconductor firm in Malaysia requires a masterful balance of capitalizing on government strategies, maintaining strict environmental and international quality compliance, and navigating complex geopolitical frameworks.
For the conclusion, Malaysia's semiconductor industry is shaped by a highly concentrated market where leading firms like MPI, Unisem, Inari Amatron, and DNO dominate. Their strategies range from cost-plus pricing in assembly and testing to value-based pricing driven by innovation, supported by government incentive under NIMP 2030 and the National Semiconductor Strategy. Compliance with strict regulations such as the Environmental Quality Act (RoHS) and the Strategic Trade Act ensures credibility in global supply chains, even though it raises costs. These requirements also push companies to innovate, expand, and strengthen ESG practice. The industry is now transforming from being cost-driven to innovation-driven, integrating AI, 5G, and sustainability. Looking ahead, Malaysia is evolving into a resilient ecosystem powered by policy and innovation. That's all from our group. Thank you.